that you will see a question on your Cartesian plane. Now, there are two types of questions. Okay, for your trial paper, which was this question here, the diagram was drawn for you. Okay, you might get a question where you may be asked to draw the diagram yourself. So make sure you know your quantities, right? You also know this formula: sine theta is equal to y over r, cos theta is equal to x over r, and tan theta is y over x, and also r squared is equal to x squared plus y squared. You have to know it. Okay, so for this question, you are given point T, which is in the third part, all right? The x value is -1, the y value is -2. So the question was saying, determine without using a calculator the value of each of the following tan alpha. Your alpha, it's a reflex angle more than 180 degrees. So before you do this question here, you're supposed to determine what r was. Okay? You're supposed to determine what r was. So if I was you when you wrote this paper, I would have done this. First thing, since I know that my x is given, my y is given, calculate r. Right? So r squared is going to be equal to x is -1 squared, y is -2, this is squared. Now, this type of a question is a very easy question. You don't have to get nervous if you know your formula. So r squared is going to be equal to 1 plus 4, and this gives you r squared equal to 5, which means r is going to be square root of 5. Right? So that's the first part. When you're answering this type of a question on the Cartesian plane, trig ratios on the Cartesian plane, make sure you know your x value, you know your y value, you know your r. Those three you have to know before you start doing anything. Alright? Now for this question where the diagram is given, it's much easier. Okay? It's much easier. Then after this, now let's find tan alpha. Now we know that tan is given by that formula. So tan alpha is going to be equal to y over x. And here, our y is given there. It's -2. X is -1. So the answer will be a +2. Also, you know that in the third quadrant, tan is positive. Therefore, the ratio for tan alpha has to be a positive answer. So knowing your quadrants is very important. Knowing your formulae is very important. Right? So this is the answer for tan alpha. Then the next one is cos alpha. Now, this was so easy. So cos alpha, it will be equal to x over r. Your x is given as -1. So this will be -1 over square root of 5. Right? That's the answer for cos alpha. So this will be 5.1.2. So it was easy. Cos alpha has to be a negative ratio because we are in the third quadrant. In the third quadrant, cos is negative. In the fourth quadrant, cos is positive. Second quadrant, cos is negative. First quadrant, cos is positive. So the ratio for cos alpha here was supposed to be a -1 over square root of 5. But then 5.1.3, okay, let me move on to the next page. 5.1.3 now. This question requires knowledge of compound angles. Okay, now if you look at your question paper at the back, okay, at the back, the compound angle identities are given at the back, just in case you forgot, or because you are under pressure, you forgot. The compound angles are given at the back, the double angles are given at the back, okay, of your information sheet. So you don't have to get confused as to what you should do. Whenever you see in trigonometry cos of a binomial in brackets, you can apply the compound angles. So the compound angle that you have to apply is the one for cos, the one with the plus. Okay? So to do this question, 5.1.3, you had to apply your knowledge of compound angles. There's no need to be scared at all. So this is cos alpha plus 45 degrees. If you apply your knowledge of compound angles, this will become cos alpha cos 45 degrees. Since there is a plus between alpha and 45, we put a minus, sine alpha sine 45 degrees. Right? Then you should know that we have got special angles here. Right? And you can't come on Monday without knowing your special angles. 30 degrees, 45, 60 degrees, 90, 150, 270, 180 degrees, 360 degrees. You have to know those special angles. So these are special angles. Alright? So from there, if I move on, let me use a different color to carry on here. So cos alpha, I know that cos alpha is equal to x over r. So when there is cos alpha there, I'll put x, which is -1 over square root of 5. Then I'll put that in brackets. Alright? Then I know that cos 45 is 1 over square root of 2. Please, cos 45 is not equal to 2 over 2. If you are doing the question without a calculator, you should write 1 over square root of 2 minus sine alpha is equal to y over r. Your y here was -2, so this will be -2 over square root of 5. Then sine alpha, that's 1 over square root of 2. So sometimes, okay, I'm just going to use the word sometimes. When you see a question for the first time, you might think it's very difficult. Yet it can be so easy if you just apply your basics. So here, you multiply numerator, denominator, and what? Denominator. -1 times -1 gives us -1. Square root of 5 times square root of 2, this will give you square root of 10. Right? Minus. -2 minus times +1 gives you -2 over square root of 5 times square root of 2, that will give you square root of 10. I'm sure you can see that we have a common what? Denominator there. A common denominator is square root of 10, which means I can simplify the numerators. So this becomes -1 plus 2 over the square root of 10. So the final answer will be 1 over square root of 10. Now, this can be rationalized to 1, okay? But if you stop there, you should be able to get your full mark. Sorry? What?
The question is simply the simplest form.
Okay, that's the simplest form. But if we want, we can carry on and multiply that by square root of 10, and that one by square root of 10, and then the answer will be square root of 10 over 10. Okay, so either way, this should be marked as correct. Okay, because you are not using a calculator. Right? In actual fact, in my opinion, and then I will stop here. Okay, will actually indicate that they didn't use the calculator. Because this answer here, square root of 10 over 10, you can only get it either if you know how to rationalize or if you use the what? A calculator. Yes. Which step? This one here. Yeah, I suggest that you show it. That's part of your working out, so you have to show it. Okay? So boys and girls, be aware that you have to know your trig ratios on the Cartesian plane. Today and tomorrow, do some questions from past papers on trig ratios on the Cartesian plane. You might get a question where the diagram is not drawn for you, which means you have to draw it. For you to be able to do that, know your quadrants, your cast diagram. Alright? Any question there? A question like this is guaranteed to be there. Right. Then the next question now is on reduction, which is part of grade 11. Okay. Now, since this question here is on reduction, it's a combination of mainly grade 11, maybe grade 12, but it's mainly grade 11. Do you know that I sent you a booklet? I don't know whether some of you saw recently, I think a week or so. A grade 11 booklet. That's a treasure for you, which you can use today and tomorrow for the final test. Right? With some grade 11 topics, like now we're only the paper 2 topics. There are past papers there in question, do those grade 11 trig questions. Right? Underneath 4 questions. They're there. And they've got the memo as well. So you don't have to worry about whether your answer is right or wrong. You utilize that. It's on the group. It's on the group. Right? Was your trig, the bulk of it, it's grade 11. Okay? You mustn't think that it's grade 12. No, it's grade 11. The bulk of the trig is grade 11. If you can master that today and tomorrow, then you should be in a good state of mind. Okay? Or rather, I would say in a good state of preparedness. Okay? So this question says, determine without using a calculator the value of the following expression. Right? So again here, no calculator. So you are given 2 sine of minus 20 degrees times sine 160 degrees minus cos 40 degrees. Right? So this was the question. Right? I'm not going to rush to just write the answer from my head. I will just take you back to the basics. Right? Here we have got a negative angle, minus 20 degrees. Right? You need to know in which quadrant is minus 20. It's in the fourth quadrant. Right? In the fourth quadrant, sine is negative. So we can write this as 2 times minus sine 20 degrees. Put that in brackets. Okay? Sine minus 20 is equivalent to minus sine 20. Then sine 160, we know that 160 is in the second quadrant and sine is positive. So this one here is going to be the same as sine 180 degrees minus 20 degrees. I'm taking you to the basics here. 160 can be written as 180 minus 20 degrees. Alright? Then cos 40 degrees, right? That one you can convert it to sine if you want. Or you can even write it as a double angle. Okay? You can write it as a double angle as well. So this cos 40, right? I have even written using 20 degrees. Right? But for now, let me not touch it. Right? I'm not going to touch it for now. Right, let's simplify this. So this will give you minus 2 sine 20 degrees. Sine 180 minus 20, that is the same as sine 20 degrees. So that would be minus cos 40 degrees. Right? So if I multiply here, I'll get minus 2 sine squared 20 degrees. I hope you can see that. Okay? This will be minus cos 40 degrees. Okay? Now, since for this question here, you're supposed to be very careful of this. In order to get to the solution, you're supposed, well, if you rush to convert it to sine, you end up getting sine 50 degrees because it's a co-ratio. Sine 50 is the co-ratio of cos 40. So you're supposed to use double angle here. Convert the 40 degrees to 20 degrees. So that can only happen if we write it as minus 2 sine squared 20 degrees. This becomes minus cos 2 times 20 degrees. Then we are now having a what? A double angle. Cos 2 times 20 degrees it can be written using sine now. Okay, so this is the same as minus 2 sine squared 20 degrees. Okay, just to take you back to the basics here. Remember, cos 2 theta can be written as cos squared theta minus sine squared theta. It can also be written as 2 cos squared theta minus 1. It can be written as 1 minus 2 sine squared theta. So there are 3 ways of writing the double angle for cosine. 3 ways. And the good thing is your question paper has got the 3 double angles under the information sheet. So you don't have to get scared. So on Monday, watch out for the double angle. Okay? Watch out for the double angle. Compound angles. There will always be questions for the final paper. Right? On double angle, compound angle. They will always be there. Right? For sine, it will be sine 2 theta. This is equal to 2 sine theta cos theta. Right? You cannot come on Monday without knowing your double angles and your compound angles. You'll be taking a huge risk. Okay? So this cos 2 times 20 degrees, I can write it like this. Where there is theta there, I'll put 20 degrees. So it will become minus, open bracket, 1 minus 2 sine squared 20 degrees. Then if I simplify this, I'll get minus 2 sine squared 20 degrees minus 1 plus 2 sine squared 20 degrees. Right? Are you following me? You see how easy it was? It was not that difficult. So minus 2 sine squared 20 plus 2 sine squared 20 degrees, they cancel out. So your final answer will become negative 1. So when you see the expression, don't get scared. Don't get scared. Okay? Don't get scared. Ask yourself, what do I know about this question? And for you to apply whatever you are supposed to apply for the question, go over your grade 11 trig. Master your grade 11 trig today and tomorrow. If it means you have to sleep very short hours, then let it be. Yes, it's only for a short space of time, and after that you'll smile. Yes. Already I'm actually, yesterday, when I saw the paper, I was even like that. When I felt sorry, I nailed the pen. So she was writing on the. I bumped into her in the corridor and she was like, when I saw it, I started smiling. You understand? I started smiling. And honestly speaking, that's an opportunity of a lifetime. I'm telling you, if you were to do a rewrite, let's say sometimes a difficult situation can turn out to be a blessing. Do you know that? I'm telling you that sometimes a difficult situation can be a blessing. People might think it's a bad thing, but it can turn out to be a what? A good thing. So there may have been some leniency in setting that paper one. And it becomes an advantage to some of you.
So the reason may be the same thing.
Well, I don't know. But I just have to warn you that from my experience, the chances of having both papers relatively easy are very slim. So maybe, listen, maybe it could be an exception, but be prepared for what? For Monday. Be well prepared. So you only have today, we are going to go over all the aspects. By 10:30 we will go over all the what? The aspects. So you just have to go home, go over your geometry. I'm not going to talk about geometry. I don't want to waste my time there. You do your best. I'll try to give you a bit of some tips towards the end, but you do your best there. Your stats, you have to know your stats. Your analytical, You go over your grade 11 analytical. If you can kill the grade 11 component, the grade 10 and 11 component, distance, midpoint, equation of a straight line, angle of inclination, right? Your grade 12 equation of a circle, then your trig, we are going over some of the key things now. Then you should be well prepared for Monday. All right? So you can then reserve some time to go over. Today is my last day to teach you. So do me a favor, I don't want to say anything. Please. Please there. All right, today is my last day. All right. Do you have any question here? All right. Let's move on to 5.3, the proof now. Right? The proof. Like 5.3, you're supposed to answer the question on that expression to simplify a trigonometric expression. It's not difficult. Okay? It's not difficult. The fact that you had a long expression doesn't mean it was difficult. Okay? You just had to apply your grade 11 trig here and grade 12. Right? So 5.3.1, the question says simplify the expression to a single trigonometric ratio. What that meant was you simplify it until you get sine only, cos only, or tan only. That's what it means. So you're given 3 cos x times sine x plus tan x times cos squared 180 degrees minus x. Right? Now, the first part of the expression, 3 cos x times sine x, somehow for now we can say it's already simplified. Okay? Let's not, you're not supposed to rush to touch it. Okay? It can be simplified, then bring in a double angle, but I don't want to bring you the double angle as yet. So we rewrite it as it is, 3 cos x times sine x. Then you know, you should know by now that tan x can be written as sine x over cos x. That's a fundamental identity. You have to know that tan x is equal to sine x over cos x. You can't come to school on Monday without knowing that tan is equal to sine over cos. Right? Then, most of you, because I marked this question for the whole grade, most learners have problems simplifying this. Okay? But I'm going to explain to you how to simplify it. Okay? Most learners, because I marked this question, I'm the one who marked the whole 3 questions for the try. Right? So I know what I saw. Okay? So those misconceptions that you had, I'm going to try and resolve them now. Please allow me to take this to a new blank page so that I can dissect it a little bit. You do life science, some of this. I hope you know what dissecting is. Right, cos squared 180 degrees minus x. This is a grade 11. It will be grade 11. Reduction. The main problem is simplifying it because of that. Now, what you need to know that cos squared 180 degrees minus x is the same as cos 180 degrees minus x in bracket. Then you put a square bracket. Whatever you get inside there, you square it. That's what it means. Right? Your final answer cannot be negative. Okay? Cannot, because a lot of learners are writing the answer is minus cos squared x. That's incorrect. Cos 180 minus x is in the second quadrant. Okay? So the answer in the square bracket, it will be minus cos x. Okay? Then you square this. If you square it, minus cos x times minus cos x, that will give you the positive cos squared. Please, you have to know this is the command, you never know. You never know. They might bring a question where you need to know this. Okay? So cos squared of 180 degrees minus x is equivalent to positive cos squared x. So let's substitute that. So here I'll put times cos squared x. Right? You following? Right. Then, so here, my suggestion would be simplify. I'm sure you can see that we've got a cos x here, plus we've got 2 cos x's here. So one of these two will cancel out with that, and you end up being left with, okay, let me use this color. So you end up being left with cos x. Are you following? So you end up having sine x, this sine x, multiplied by that cos x. Okay, so you get 3 cos x times sine x plus, that one will give you, okay, if I start with cos x and write it as cos x times sine x. I'm sure you can see that they are like terms now. This is alike with that. So we can write 4 cos x times sine x. But then the question was saying simplify the expression to a single trigonometric ratio. So this is not the final answer because we have got 2 ratios. We have got cos x, we have got sine x. We need to simplify so that we eliminate either sine x or cos x, so that our final answer must have either cos only or sine only. Okay? Now, I hope you remember your double angle. Sine 2 theta is equal to 2 sine theta cos theta. So that's the one that you're supposed to apply. So this can be written as 2 times 2, well, I can start with sine because of multiplication, 2 sine x times cos x. So the final answer will be 2. Then the left hand side, there, which is sine 2 theta, where there's theta, they will put x, so it will be 2 sine 2x. That would be the final answer. So this was not as difficult as it seemed. Okay? It wasn't as difficult as it seemed. And also on Monday, have a positive attitude. When you see the question, ask yourself, what do I know about this question? Do I know my reductions? Do I know my trig ratios? Do you know your double angles? Do you know your compound angles? So we go back to grade 11, reduction formula. Okay, that revision booklet that I sent you, the week or so ago in grade 11, you need to utilize that. Answer the questions that are there on sheet. They will prepare you for money. Then you do the grade 12 component, which is both the double angle and the compound. Yes? Which part? Okay, right. Do you see that there is multiplication here? Yeah. So we have got cos squared x, but the denominator here is cos x. Because of this multiplication means this cos x and one of these 2 cos x's can cancel out. Yeah. That's only true because of multiplication. If there was a subtraction here or addition, we could not do that. So it's more like this. If I take you to algebra, it's like this. Okay, let's say you have got y over x times x squared. If I ask you to simplify that, what would be the answer? Is it? Yx. How did you get it? Yes, that's the same technique I used. And that's a very important technique in medicine when you are doing some trigonometric calculations, especially the ones with expressions. You have to know that if there's multiplication, you can cancel out a denominator and a what? And a numerator. If they are the same. Right? Right, Aaron? So make sure you know your reduction. That's from grade 11. You know your compound. You know your double angle. So this whole weekend, when it comes to trig, you should be singing reduction, compound angle, double angle. Maybe you should dream about the Cartesian plane as well. Right? The Cartesian plane, you should dream about it. Double angle, reduction, compound. Right? Now we are going to proofs of identity, the next question. All right. Then 5.3.2. Can I have your attention now? You know what? I want to be honest with you. This paper wasn't as difficult as what it seemed. Yes. You know, 5.3.2 says hence in maths or even in English. What does the word hence mean? Because you know, I understand that some of you are not first speakers of English, but it is extremely important for you to know that in maths, if you see the word hence, what does it mean?
It's hence or.
Yeah, what it means, just to say it in simple terms, if you pay attention, because you are most likely to see it on Monday. Right? You are most likely to see it on Monday. In maths, if you see the word hence after answering a question at the beginning or at the top, it means use the answer you got at the top to answer this one. What it means that there is a connection between 5.3.1 and 5.3.2. That's what it means. So if you didn't get 5.3.1 right, you are at a high risk of getting 5.3.2 wrong. Because there is a relationship. If you can't get that single trigonometric ratio in 5.3.1, you won't be able to do 5.3.2. Alright? So, we got it. It's 2 sine 2x. Now they are saying, hence, write down the range of f of x equals. I'm sure you can see that this is equivalent to that. But we have simplified this whole expression to this one here. Which means we can replace this expression by this one. Are you following? Therefore, 5.3.2, it means that we can write that expression as f of x equals 2 sine 2x. That's a grade 11 trigonometric function. It's a grade 11 trig function. So, how do you find the range of this? What is range? You wrote it in the exam yesterday. Where probably it was there. What is range? Huh? What is range? Yeah. Range is just a set of all the what? Y bar. Range, you have to know it was paper 2 trig, you get a trigonometric function, whether you like it or not. It will be there. Trigonometric function. You have to know what range is, what domain is. Range means the set of all the y values. So you identify the minimum, you also identify the maximum. So this function here, 2 sine 2x, there's got an amplitude, which is 2. That's the maximum value of y. The minimum is going to be negative what? Negative 2. Right. Exercise. Sketch this graph. Now that you have sketched, I'm sure you can see that the minimum is what? The maximum is what? So your answer here, it was supposed to be y is an element. You start from negative 2 to 2. This was very easy. It was very easy. What? Right? You can also write this answer as minus 2 is less than y. You must put an equal sign, is less than or equal to positive 2. You can also write it like that. Okay? Are you following? Please know what range is. Range is the set of the y value. You have to know it on Monday. Then you might get a question asking you, what is the amplitude of this graph? Right? The amplitude has got a formula, okay, which I'm going to tell you now, which you need to know. If you can't get it from the equation, then amplitude, please write this down somewhere. It's equal to y maximum minus y minimum all over 2. Okay? So for our question here, our maximum is a 2, minimum is negative 2. So you get 4 over 2. The answer will be a 2. And that 2, you can also get it from the equation. It's this one here. Please, amplitude is always positive. I'm going to shout there. Amplitude is always positive. If the question comes on Monday saying, write down the amplitude, you can't write a negative answer, please. Amplitude is a distance. And distance can never be what? Negative. So memorize this formula here. And also memorize this formula that I wrote here. You need them, please. Okay? Just in case you get a question on sketching, your period is got 360 over b. Sometimes they may also ask you to determine the value of this b. So you need to know that formula. Your step on your calculator is equal to the period divided by 4. To get the step, you have to get the period first. Get your period first. You following them? Right? Is there anybody with any question before I get on?
So how do you get the B?
You have to determine the period of the graph. So from this formula, B will be equal to 360 degrees divided by the period. So find the period, then you divide 360 by that period. You get your B value.
The period is 2.
Yeah. Okay? Are you following? Are you following? Yeah. Make sure you know that. Right, let's carry on. So I have answered 5.3. Now let's move on to the next question. And I've also discussed here the trig graph. Okay? You can also go home and attempt other questions where you sketch. You have to come prepared to answer questions on trig graph. I'm going to talk about the question which was in this paper as well, just now. Right? So I've discussed this. Then, proof of identity. But, boys and girls, this is in, okay, come rain or shine, whichever the case you call it. Right? I'm sure you know that the sun rises from the what? East. That proof of identity will be there. It's like the sun rising from the east. You can't come on Monday, you can't do a proof of an identity. don't have the guts to come. Okay? Don't have the guts. You have today and tomorrow, right? After we finish here, you go home straight. Go home. Not anywhere else. Go home, you relax a bit, you carry on preparing for your maths. Right? And you must shut the door for anyone now. No phone call, nothing. Alright. So this is cos 3x over cos x. This is equal to 4 cos squared x minus 3. Right, can I have your attention here, please? Can I have your attention? I want you to look when I'm doing it. Right? When you're doing a proof of identities, okay, there are things that you are expected to know before you start doing the question. At this level in grade 12, you have to know your double angle, know your compound angle, know your fundamental identities from grade 11. Tan is equal to sine over cos, sine squared plus cos squared is equal to 1. You have to know that. Okay? You also have to know that sometimes you may need to factorize, sometimes you may need to find the LCD and so on. Okay? So here, you can't simplify the left-hand side. This is already simplified. So you can only simplify the left-hand side. But I'm sure you can see that there was a 3 here. That 3, we have to split it up into 2. That is 2x plus x. We are applying now compound angle, also a double angle as well. Right? So, first thing you're supposed to say, left-hand side is equal to cos 3x over cos x. This will be equal to. Right? We break up that 3x. Break it up. And then you get cos 2x plus x. This is all over cos x. The fact that we now have 2x plus x and there's cos involved, compound angle. Compound angle. Right? So this becomes cos 2x times cos x. There is a plus here, so it becomes minus sine 2x, then sine x. This is all over cos x. Okay? I hope you can see what I did there. I'm not guessing, right? Then, from here now, we can't introduce tan, so there's no way that you can try to divide sine over cos, complicating things. Convert. My suggestion here, since we have got, this must be your indicator that you can't have sine. Okay? So this sine here, it must disappear. That also must disappear. So the only way for making sure that sine disappears is convert this sine 2x to 2 sine x cos x. Okay? Because the right hand side doesn't have sine, it means we have to eliminate sine. Right? So on the next page, I can write also, before I carry on, this cos 2x, we don't want it. So we're going to convert it to a double angle for cos. So it's going to become 2 cos squared x minus 1. That is equivalent to this. So someone might say, what is he writing? Cos 2x, okay, is equivalent to 2 cos squared x minus 1. It's here. Information sheet there. The third compound angle. Sorry, double angle. Third. The third one. That's the one that I'm using there. Are you following? Huh? Are you following? Alright, then. So from here, then I'll just write my minus. Okay, actually it's times. We've got times there. So, okay, to make things easier, I'll just put this in brackets. So I'll put cos x. right? Then that sine 2x, I can write it as 2 sine x cos x. So this becomes minus 2 sine x cos x. I'm not guessing, it's also here on the information sheet, the double angle for sine. It's there at the bottom. Sine 2 alpha, got 2 sine alpha cos alpha. Okay? Which part? Everything is very good. Okay. First and foremost, this is a double angle. Okay? For cosine. This is also a double angle. For what? For sine. Do you see that on the right hand side here, we don't have a double angle? Do you see that? By double angle, it means we don't have a 2 multiplying x. You understand? We don't have a 2 multiplying what? X. So since we have got cos 2x, means we have to eliminate this cos 2x and write it in a form which doesn't have a 2. We also do the same here for the sine. We don't want the 2 to multiply x, so we convert it to a form that is x only. Fortunately, this cos 2x is equivalent to 2 cos squared x minus 1. Okay? Multiplied by cos x. That's why I put it in brackets, because it's multiplying cos x. Then sine 2x, okay, sine 2x is equivalent to 2 sine x times cos x. Cos 2x is equivalent to 2 cos squared x minus 1. I hope you remember that this comes from the compound angles. Please. When I told you this, I derived where this comes from. Compound what? Angles. If you split this 2x into x plus x, then you apply compound angle. You can simplify and come to this.
So we have to learn all the proof.
Well, I would suggest that you just know it's not like they will come, but you might need to utilize that. But the proof of the compound angle or the double angle, well, it may not be directly examined, but just knowing it can help you to answer the question. Okay? Alright. Before you want to just say that you got this and that. And be aware that this double angle here has got 3 forms. Right? It can also be written as 1 minus 2 sine squared x. Right? It can also be written as cos squared x minus sine squared x. You have to know that the double angle for cosine can be written in 3 ways. You never know which one in your paper on Monday you are going to require. So be ready for all 3. You can't come on Monday, you don't know that cos 2x is equal to this, it's also equal to that, it's equal to that. Are you following what I'm saying? Good. Now, when you see a question where you need the double angle, you're going to see a question where you need the compound angle. So be ready for that. Okay? So let's carry on from there. So this is times cos times what? Times sine x. Okay, that my tool is hiding. Let me unhide it. So this will be times sine x. Okay? Now this is so nice because I can simplify this. Remember the denominator, what? Cos x. So I can split the numerators. There are 2 numerators, just to remind you there are 2. Okay? This binomial multiplied by that, it's 1 term. Then this is also another term. So I can write that as 2 cos squared x minus 1 times cos x all over cos x minus 2 sine x times cos x. Well, allow me to multiply sine x times sine x will give me what? Yeah. Okay. So I can put squared x, this is all over cos x. And I'm sure you can start smiling there. right? This cancels with that. This one cancels with that. Okay? Then, if I remove brackets there, I'll have 2 cos squared x minus 1 minus 2 sine squared x. Do we have sine on the right hand side there? No. So how do you eliminate it? Use the grade 11 fundamental identity. That fundamental identity is sine squared theta plus cos squared theta is equal to 1. Therefore, sine squared theta is equal to 1 minus cos squared theta. Are you following? Are you following that? Right? So I can write this now as 2 cos squared x minus 1 minus 2 times 1 minus cos squared x. Then this will give me 2 cos squared x minus 1 minus, with minus 2 times 1 will give me minus 2 times minus cos squared x, that will be positive 2 cos squared x. Right? This is interesting. Right? I'm sure you can see that these two are like terms. These two are like terms. I hope you can see this. This one here and that one, they are like terms. Yes. I replace this sine squared x by 1 minus cos squared x from grade 11. So this negative 2 times positive 1 will be negative 2. Negative 2 times negative cos squared x will be a positive 2 cos squared x. Are you following that? Now, do you see where this 4 comes from? This 4 here. Huh? It comes from 2 cos squared x plus 2 cos squared x. Then you get what? 4. You'll be smiling. You'll be writing it whilst you're smiling. Right? Then minus 1 minus 2 minus 3. Then you say, therefore, left hand side is equal to right hand side. Are you following? I have to be honest with you that, number one, trigonometry has got more marks than any other topic, okay, for the paper that you write on Monday. That's based on the 2021 examination guidelines. You're going to have more marks than any topic. If you know your trick, you just answer the start, the trick, you pass. You're done. Yes, you see, check this out. If you know your trick, right, it will have almost like 50 marks plus.
Yes, sir.
Right? Out of 150, trick only. Right? Now, if you answer the start, you go to trick, you skip analytical, you don't answer geometry, you can pass the paper. Please, that's only if you know. Okay? And then you can come out, listen, you can come out of that paper knowing and being guaranteed that come January, you see a pass on your metric certificate. Okay? Now, just imagine then if you answer the analytical, you kill it, and then try your best in circle geometry. You'll be smiling. You have a big smile. You have a big smile. Okay? All right. Oh, okay. Now, the next question is on the general solution. General solution. Again, come rain or shine, right? You have to know the general solution. It's guaranteed. And usually, it will have 5 marks, or sometimes 6, but most of the time it will be 5 marks. So, the revision booklet that I sent you a week or so ago on grade 11 where you go over your trick, you see questions on the general solution. Do those questions. That will prepare you for Monday. Yes? Alright, so can I have your attention? Now, most learners were scared when they saw this question. Can I have your attention? Right. Most of you were scared when you saw this question. But I can tell you it was very easy. It was very easy. The reason why you got scared was it was an exponential equation with some trig in it. Or it was a trig equation with some exponential equation in it. So you're given 3 times 2x. Okay, so 3 to the power of 2 times x. So it was 3 to the power of 2 times x. Right? Minus 3 to the power of tan x minus 1. Or rather, it's a plus 1. This is equal to 54. You know that this question here, it was not as scary as you thought it might be. See, this is it's an exponential equation under trigonometric equations. You're supposed to break it up, so you break. Okay, this one you leave as it is 3 to the power of 2 tan x. Then you break this up, you get 3 to the power of tan x times 3 to the power of 1. This is equal to 54. And before what I just did, those of this plus. Are you following that? I use law 1, right? Then, from there now, you can see that we can break it up again. See, there's this tan here. If you look at it carefully then, we've got this one here. So, we can write it as 3 to the power of, okay, well, I can write it 3 to the power of tan x squared. Like that. You can write it like that. Because this 2 times tan x will give you 2 tan x minus 3 tan x times 3 to the power of 1. Then you can bring that 54. And then you get 0. So you end up having to create more like a quadratic equation. And you have to use the K method. Right? The K method. So you say let K be equal to 3 to the power of tan x. Are you following? You remember the K method, grade 11, term 1. Right? So this becomes K squared minus 3K minus 54 equal to 0. Yes, where there is 3 to the power of tan x, we put K there. 3 to the power of tan x, we put K. You end up getting this equation. Look here. 3 to the power of 1 is equal to 3.
Oh, makes sense. Now I see.
3 to the power of 1 is equal to 3. There is multiplication here. 3 to the power of tan x is equal to k. So 3 to the power of 1, which is 3 times k, will give you 3k. Are you following that? Huh? Okay, look at Alright, I said this question here, you could not do it without the K method. Alright? You could not do it without the K method. The question was testing your knowledge of exponential equations and trig. Okay? So I said let K be equal to 3 to the power of tan x. Do you understand that part? Which means where I have 3 to the power of tan x, I put K there. Multiplied by 3. What is K times 3? 3K, which is what I want here. Right? Then need to factorize that. Now to factorize it, K minus 9 times K plus 1, so it's plus 6. This is equal to 0. Now you start smiling. Then this K equal to 9 or K equal to minus 6. Are you following that? Which part is this? Which part?
Which part?
Be very careful. Minus 9. Minus 9, Tiara. Minus 9 plus 6 gives you minus 3. Wait. You can't get a K which is negative.
So I'm calculating saying the answer is minus 9.
Yeah, just check again what you did.
You have to change it again. I did.
Check the equation which you put. Check again. Huh?
I don't put a minus with 3.
Yeah. Okay, so from here now, then we say, I don't want this. Let me go back. So from here we now say when K is equal to 9, right? It means 9 is going to be equal to 3 to the power of tan x. You see that?
Yeah.
Then you can write this as what? 3 squared. That's 3 to the power of tan x. The base is the same, therefore the exponents are what? Are equal. So this gives you 2 equal to tan x, which I can write as tan x equal to 2. Then I bring in my general what? Solution, which will be x is equal to shift tan of 2 plus k times 180 degrees, where k is an integer. And what is shift tan of 2? 63.43 degrees plus k times 180 degrees, where k is an element of z. So I'm not done. I'm not done. What about when k is minus 6? Right? This gives me minus 6 is equal to 3 to the power of tan x. Can you convert minus 6 to a base of 3? No. So this is what means that k equal to minus 6 is not applicable. Okay, it's invalid. Which means you only have one answer. That's your answer. Okay? You following? Are you following? Right, I must be honest with you that this was a rare question which involved exponential equations. Okay, it was a rare question. It's not a very common question. Now, you need to know your general solution for sine, general solution for cosine.
So it's in terms of
Right? Yes. For sine, there are 2 general solutions. For cosine, there are also 2. Yes. The question was saying, determine the general solution. A general solution is an equation. You know that a general solution is an equation?
Yes.
Yeah, you must know. So you stop there. If the question was saying, determine the value of x, that's when you start substituting k equal to 1, k equal to 0, k equal to 2. Okay? But here, the question was saying determine the what? General solution. A general solution is an equation that you can use to determine all the possible solutions. So this is the general solution. That clear? Yeah? Okay, let's move on to the next question. Now the graph. Right? I've already started talking about the graph. You have to know the graph. Sketching, interpretation. Okay? You have to know. You practice how to sketch, how to interpret today, tomorrow. Use the grade 11 revision workbook that I sent to you, because 3 graphs are not taught in grade 12. They are grade 11 work. So go over your grade 11 stuff. Right? So for this question, you are given the 2 graphs. One for cos, that's minus cos x plus 1, and the other one for sine, 2 sine x, 2 sine x plus 30 degrees. Then the question now, okay, the question. You may get a question like this, you never know. If the question comes where you don't have to sketch, then you must be happy. Okay, where you don't have to sketch. So this question was a little bit tricky because it says, for which values of x between -1, 8, and 90 will f of x times g of x be greater than or equal to 0? I think I've said this again and again. F of x is y, g of x is y. It's only that we have got two graphs. So we've got y for the cos graph, y for the sine graph. So the question is saying, tell us what values of x are such that if you multiply the y values, okay, so this is 6.11. So 6.11, it says f of x times g of x is greater than or equal to 0. What this means is, what values of x are such that if you multiply the y values for the cos graph times the y values for the sine graph, you all get a product which is 0 or greater than 0. Right? Yes? Yeah, the answer should be -30 to 90 degrees, not positive infinity. It's based on where the graph stops. The graph stops here. So it's somewhere there. From -30 to what? To 90 degrees. But how do you explain how he got the answer? If you want to make the y values positive when you multiply them, it means both must be positive or both must be what? Negative. Now, if you look at this graph here, I hope you know, by now you should know this, that if the graph is above the x-axis, it's positive. I'm going to repeat that. If the graph is above the x-axis, then it's positive. If the graph is below the x-axis, then it's negative. Are you following what I just said? When I say positive or negative, it means the y values are positive when it's above the x-axis. The y values are negative when it's below the x-axis. So if you look at f starting from here, f is positive, positive, positive. But y in that interval, sorry, g is negative. So that's not the interval we want. The interval we want is when both of them are positive or both of them are what? Negative. So they are both positive from here up to there. So your answer to that question, it should be 30 degrees minus 30 degrees is less than or equal to x. X is less than or equal to 90 degrees. That would be your answer.
So just by observation.
Yes, you don't have to do any calculation. You don't have to do any calculation. Then, you know what? 6.1.2 is like you are doing grade 11 work. Then it says, for what values of x between minus what? -180 and 90 degrees is g of x equal to -1. Look here. Look here. G of x is equal to 2 sine x plus 30 degrees. Then, what values of x are such that g of x is equal to -1? It means where there is g of x here, we can put what? -1. And you can even solve it. It's a trig equation. If you can't see the answer on the graph, so I'm going to show you both ways. Let's start with the graph itself. Right? G of x equal to -1 means what is the value of x when y is what? -1. Okay? So if you go to the graph, okay, just allow me to indicate because I can't see. I can't see. Okay, you need to know that the amplitude of this graph is what? For g of x? 2. So here you are going to have -2. There you are going to have +2. So -1 is somewhere there. So if you go that way, you go up, you get to what? -60. Do you see that? So your answer there was what? -60 degrees from the graph. But let's prove that by solving that equation as a second method. So the question could be answered using the graph, that will take you a few seconds, or solving the trig equation, that one there. So we could solve this and write as 2 sine x plus 30 degrees is equal to -1. Do you know what grade that equation is? It's a grade 10 trig equation. Right? Then to solve this, first we divide both sides by 2. If I divide both sides by 2, like that, I'll get sine x plus 30 degrees is equal to -1/2. Then you take the shift sign of -1/2. So that will be x plus 30 degrees is equal to shift sign of -1/2. This is nice. And then you get x plus 30 degrees is equal to -30 degrees. You can prove that. What is shift sign of -1/2?
So it's 30.
Shift sign of -1/2. So we get x equal to -30 minus 30. And you get -50. So you could do it using the knowledge of trig equation, or you do it on the graph. You see that? What I just did in using trig equation, solving by using trig equation, it's grade 10 way. So the question was not as difficult as you might have thought it is. Alright? Are you following? Let me warn you. When you're answering questions on trig graphs, you have to know trig equations. Okay? You can't be in the dark about solving trigonometric equations. So you too. Can you out of the lesson? Right? Then the next question now. This was quite interesting. It said the y-axis is moved 90 degrees to the right. I wonder what you thought when you saw that the y-axis is being moved 90 degrees to the right. Right? Determine the new equation of the graph, originally called f in its simplest form. Who can tell me another way of rewriting this question based on what you understood about graphs so far?
Wow.
See, I am saying, how else could this question be phrased based on your understanding of graphs? Here, we are moving the y-axis, right, to the right. How else can we do it? We can move the graph to the what? To the left by 90 degrees. Are you following what I'm saying? Alright, okay, look here. Alright, look. Listen carefully. Let's say this classroom would move. Can you two pay attention, please? Let's say this classroom could move horizontally, right? I can move, right? I move to my left, right? I'm right in front of police, right? I'm now here. I move maybe a meter or so from where I was to the what? Left. How else would we be aligned if I was still here? It means the classroom has to move until the police is here. So if the y-axis can move 90 degrees to the right, it's the same as saying the graph is moving 90 degrees to the left.
Oh, yeah. So wait.
Are you following what I'm saying? Okay, look here. There are two ways. Listen. There are two ways in this whole world that police can come and be face to face with me. Either I move like this and I stand in front of him, or I remain in my position. Then the classroom moves together with him. Then it comes here. Richelle moves to her left, and the rest of you move to the left. But the best way is the case where the graph moves. Do you understand? So, if the graph is going to move 90 degrees to the left, it means our equation, remember f was, it was initially f of x, it was minus cos x plus 1. So if we move 90 degrees to the left, it is the same as moving the y-axis to the right by 90 degrees. So this will become h of x equals minus cos x. If you move to the left, that will be plus 90 degrees. Plus 1.
Minus.
Yeah, it's a whole solution.
Wait, that's why it's untitled.
Oh.
All right. And then let's do the last question. All right, let's do the last question. Let's do the last question. All right. I just want to give you some very important hints to answer this question. And this question was very easy. Like this question was very easy. You know, when I analyzed your trigonometry, which was in this trial paper, I found that it was not as difficult as what it seemed to have been. Right? First thing, when you see questions on 2D and 3D, what must come into your mind is trig ratios. Sorry, girls. Trig ratios. On Monday, you're going to see questions like this. Whether you like it or not, the sign counting. Actually, it rises from the east. That's the same way. You're going to see a question like this. Know your trig ratios from grade 10. Know your area rule, sine rule, cosine rule. Reduction formula, sometimes compound angle. Right? So the question was saying, show that x is equal to 5 divided by 2 cos theta. Right? Now, if I want to write x, it means it was wise, can you pay attention please, to determine the length of AD. Okay? You're supposed to determine the length of AD in terms of x. Are you following what I just said? Listen, if you are to write x equal to 5 over 2 cos theta, it means that the only way you can connect that 5 with x, how can you get this 5 here? The only way you can get the 5 together with the x is by calculating AD in terms of x. That's the only way. Do you understand? To have x and 5 in the same equation, you have to find the length of AD in terms of x. So, if this is 2 theta, this is 2 theta, so this will be the opposite side, that's the hypotenuse. Okay? So you're supposed to say sine 2 theta is equal to AC, which is what? X, over the hypotenuse, it will be AD over the hypotenuse, which is X. Okay? Yes. So AD will be equal to X sine 2 theta. But do we have 2 theta here? Do we have 2 theta in our equation that we are supposed to show? No. So what do you know about this? Sine 2 theta is equal to what? It's a double angle, it's equal to what?
2 sine theta.
Yes, so we could write this as AD equal to X times 2 sine theta, so it becomes X times 2 sine theta cosine of theta, which is the same as 2x times sine theta times cos theta. This is theta. Are you following? x times sine 2 theta is the same as x times 2 sine theta times cos theta. So you get 2x sine theta cos theta. So this is AD. Are you following that? Then, now that I know the length of AD, I'm now going to use triangle ABD. So this is now my reference angle. This is now the opposite side, that's the hypotenuse. Are you following? Huh?
Yes.
So we can end up having sine theta is equal to the opposite side, which is equal to AD, and AD is 2x sine theta times cos theta. This is all over. This is all over. The hypotenuse, which is what? 5. Do you see that? Then, if I cross multiply, I'll get 5 sine theta is equal to 2x sine theta times cos theta. Now I'm smiling. The sine theta cancels with that sine theta. Do you see that?
Yes.
Right? Then, do you see that?
Yes.
Then you'll be left with 5 on the right, and then you have 2x cos theta. So to make x the subject, you divide both sides by what? 2 cos theta, so you get 2 cos theta is equal to 2 cos theta. This cancels with that, cancels with that. Then we are done. So therefore, x will be equal to 5 over 2 cos theta. So it wasn't very difficult. It's just that some of you, you saw the diagram, then your brain shut down. Please, don't be scared by the diagram. Don't be scared by the diagram. Sometimes the question can be so easy. Okay? Don't be intimidated by the diagram. You must intimidate the diagram. Alright? Right, then let's move on to the next question. Is there anybody who has got any question? Are you following what I did? I just used trig ratios and double angle. One minute. If you look at this triangle here, ABD, we calculated AD. Okay? We know here this angle is theta. This is the hypotenuse here, 5. From grade 10, we were taught that sine theta is equal to opposite over what? Hypotenuse. Your opposite side will be AD, and AD is equal to this. Your hypotenuse is 5. So, sine theta will be equal to the opposite side, which is AD, is 2x sine theta times cos theta over the hypotenuse, which is 5. The denominator here is what? 1. You cross multiply. 1 times this gives you 2x times sine theta cos theta. 5 times sine theta gives you 5 sine theta. Then, because there is multiplication here, this can cancel with that. Because of multiplication.
So you can sine.
Yes, if I give you, okay, look here. If I give you, say, 5x, right? 5x, wait, 5x is equal to 3xyz. If I say here, solve for y, I hope you are aware that these two can cancel. You should know that now, by now. It's not something that you should be surprised about. No. You should know that by now. If I divide both sides by x, the x and the x cancel. That's where it cancels. So if I divide both sides by sine theta, this sine theta and that sine theta will cancel. Okay? Right. The last question before we go. Right. The last question now, this is now easy. It says, calculate the length of BC if it is given that BAC is 112. So this angle, that's BAC, is 112 degrees, right? Now I want you to be aware that BC is part of triangle ABC. So we know what AB is, it's 5 units. AC is X. So we need to find the length of X. That's why we're given the angle theta. So we use this expression here to find what? X. You follow what I'm saying? So X is equal to 5 over 2 cos theta. But cos theta is equal to 30 degrees. So this will be 2 cos 30 degrees. What will this give you? What is 5 divided by 2 cos 30 degrees? So you get 5 square root of 3 over what? 3. Then, so this is 5 square root of 3 over 3. Now, to get the length of BC, we know the angle which is opposite BC, we know the length of the two sides that form the angle. Which rule can you use? Sine or cosine? Cosine. Then use the cosine. So it wasn't as difficult as we think. So here it will be BC squared is going to be equal to AB squared plus AC squared minus 2AB times AC cosine of what? BAC. Then you substitute. What is AB? It's 5 squared plus AC is 5 square root of 3 over 3 squared minus 2 times 5 times 5 square root of 3 over 3 times cosine 112 degrees. Right? You simplify that. Okay, let me simplify it a little bit. So this will be 25 plus 25 times 3, that's 75 over 9 minus 2 times that. Okay, well, that's 10, that's 50. 50 square root of 3 over 3 times cosine of 112. So you get BC squared. What is that equal? You have to be a guru of your calculator. Yes, you must multiply that by cos 112. She is getting 44,14. 44,15. So it's 44,15. What's the square root of that? 6,1. The square root of this 6,65 units. And then